problem 8.3.3c. So we want to find the bound for the approximation error for the logarithm of x plus 3 over interval -1. From the previous questions where we used the t3 tilde x, we use the roots of this t3 tilde x to construct the Lagrange interpolating polynomial. So remember that for Lagrange interpolating polynomial, the error term is going to be, so because we use the 3 points, so the error term will be just this, x minus x0, x minus x1, x minus x2, where this x0, x1, x2 are the 3 roots for the t3 tilde. And then we also have this term. So this is the third order derivative for f at some point you can see between these 3. Between these 3 means that you just look at the smallest one, largest one, that you can see some number between them, between those 2. Okay, so we just need to bound this and then also bound this. So for this term here, we just need to check f of x is this, so f prime is this, f double prime is this, and f triple prime is this. So now the function is defined over this interval. So this denominator here can be as small as 1. Okay, and so that's why this thing here is upper bounded by 2. Okay, because this denominator can be as small as 1. And on the other hand, it has this because we use the 3 roots for the t3 tilde. So this thing here is just the t3 tilde. Okay, and these are the 3 roots for t3 tilde. So that's just t3 tilde. But on the other hand, we know t3 tilde is the monic version of the Chebyshev polynomial. So the original version is, or the non-monic one is this t3. The relation is just by this additional scaling. Now we know that the t3 here is something like a cosine of 3 times arc cosine of x. So the magnitude of t3 will be -1 to 1. That's why this term, or I should say this term, it should be bounded about by 1/2 squared. Okay, so that's why this is bounded by 2. This one is bounded by 1/2 squared. So altogether, this is giving us this upper bound. So that means we use the 3 roots for t3 tilde to do this Lagrange interpolating polynomial for this thing here. Then the error is going to be upper bounded by this value.